And the final one, we're still solving this inequality. Again, we really would have choices of factoring, completing the square, or quadratic formula. I'm going to disregard factoring on this one because at a quick glance I can tell that there aren't any factors of 1 that I can use that add up to a 4. It's only 1 times 1 and I can't add or subtract to get a 4, so I'm going to disregard factoring. So now my choices are limited down to completing the square or quadratic formula. Given the choice between the two, I typically will hedge a little bit towards completing the square if this number is even. And since it is, I'm going to go ahead and I'm going to group the x's and I'm going to complete the square. And rather than putting the equal 0, like I said in the other two videos, I just want to think about it equaling 0. So complete the square, balance, and I'm going to work it from there. So half of 4 is 2, 2 squared is 4, so I'm adding 4, so to counteract it or balance it, we subtract 4. This factors into x minus 2 squared. Then we have minus 3 equals 0. Now I want to solve this for x, so once we have it in this vertex form, they're relatively easy to solve. We're going to add 3, then we're going to square root, so x minus 2 is plus or minus the square root of 3, and then I'm going to add the 2, which is 2 plus or minus the square root of 3. Now keep in mind, if you wanted to, you could do with a quadratic formula. It should give you the exact same values what we just found here, and these are the inputs that create an output of 0. So one of these numbers is 2 minus the square root of 3, which has to be to the left of the other number, which is 2 plus the square root of 3. Now I'm going to go back and see if I have a smiling or a frowning curve, and because this leading coefficient is positive, I know it's going to be a smiling parabola or curve. Okay, now I need to interpret the inequality sign. So now I come back, and this is really the first time I have to deal with that inequality sign. It says less than, and I find the spots in the graph where our graph goes below or is less than 0. So here is where it's below the zeros, because this is a point of 0, and this gives an output of 0. These are below, which is less than 0. These are above over here, which we don't really want in this problem because they're greater than 0. And these are above on this side, and they're greater than 0. So once again, in our solution set for this one, we want to be below, so it's every value that we have in between our two anchor points. And the only thing different about this graph is I must open up those circles because we do not get to include the anchor points, or our endpoints of 2 minus the square root of 3 and 2 plus the square root of 3. So in interval notation, because we don't get to include them, we use a parenthesis, 2 minus the square root of 3, comma, 2 plus the square root of 3. We're going to go all the way from this value up to that value, but not inclusive. Solution set. Here's your graph. It's a solution set. It's really just a matter of solving your quadratic equation, sketching a very simple parabolic curve that smiles or frowns, and interpreting where it is below or above. Keep in mind, when you have less thans, they're below, greater thans are above.